Welcome to this video in which I'm going to show you an extension of this activity-based costing exercise into scenario management. I've been using this exercise for years. It's an old exam question or a textbook question, and it's designed only to introduce the concepts of activity-based costing in this way. Three products, sales and production units are the same, so there's no inventory complications. And here's the inputs per unit, raw materials, direct labor, machine hours. And here's the cost driver, setup, packing, receiving, and engineering details. For example, in this period, in any period, to make 90,000 units of A, it takes 5 production runs. In other words, 90,000 divided by 5, on average, it's about, what's that, 19,000 per run, as opposed to 50, as opposed to 7 deliveries for packing, and so on. And as with any activity-based costing exercise, the real focal point of the whole thing is here, the overheads. So we've conveniently, or by design, we've found the setup cost pool, £75,000, machine overhead cost pool, £1 million, and so on. As you can see, 3375000 is the total overheads. And this exercise does these two things. Number one, it asks you to calculate production cost on the basis of machine hour overhead absorption recovery. I'm going to write down here then, calculate the machine hour rate here. We apply this overhead rate here according to number of machine hours in this case, direct labor hours in the other case, and that gives us the traditional cost accounting total cost, production cost. For ABC, it's using machine hour rate for machine overheads only. Then we need to calculate the cost driver rate on these bases, which we then apply here. So for example, let me just do one of them, equals setup overheads divided by cost driver units. So setup overheads, 75,000 divided by 65. That's the cost driver rate for setups. Every setup on average is costing £1153.8462 in overheads for every setup. We then apply that in this way, equals average cost per setup multiplied by the number of production runs for product A, and then divide by the number of units produced by product A. Press enter, and that gives us 6.41 pence. That's how ABC works. You add them all down, and we've now got the ABC total production cost. And what I set up was, I added to this question to this. Let's imagine that there's a 100% markup on production cost to set the selling price. And that's what this exercise does. What I've done to enhance this question is this. I've now created a series of scenario values, and to help understand what's going on, I've worked through this question. Let's have a look at it. All the answers are here for the ABC, that is. Machine hour rate, setup costs, all the way down to engineering. And so now we know that 65, 85, 163, they are the ABC total cost of production. I've got the traditional cost accounting cost here. And so therefore, top left-hand corner, they're the summary of each of those. But we've done this through a scenario, so let's watch what happens now. This is the worst case, where we find total production cost by ABC of those. But we've got two other scenarios. Best case. And in the best case, this falls by about $4. What's that? Fall by $3, something like that. And this falls significantly. In the most likely case, which is the base case that I started with, this is what we found. How did I do it? Well, all I did was, over on the right-hand side, I set up my scenario input data. It's not a massive change, but I needed to set up in this way. So we want product ABC. This is the current state of affairs. Most likely, you might even call it the base case, 90, 30, 15. But let's get ready in case something marketing does or production does, changes things, such that production of A falls to 80,000, B to 27,500, and product C to 12,500. The machine hour traditional, and by machine hour, by ABC. No, nothing to shout about that. That's the way it is. Then I needed to create. I did create scenario data for number of production runs, best case, worst case, most likely, number of deliveries, number of receipts, and number of production orders. And that's it. So I now need to feed that into what's on the left-hand side. And how did I do that? And there we are. The way to get these to respond to these, to filter. Let's see what we filtered. So we filtered J5 to L7 with the include of I5 to I7 equaling B4, which is this. In other words, whatever it says there corresponds to one of these, and the best case then, it goes, because it's a filter function, it goes and finds this and then says, all right, these are the three values that it wants under the best case. And that's exactly what we found. How about these then? Where do we use them? Well, the color coding gives us a clue. So I've highlighted that in blue, light mid blue. And if we look down here, I've got another filter function for the number of production runs. Let's just check it. J10, L12, include I10, I12, again equals whatever's in B4. That's it. I do that for number of receipts, number of deliveries, number of production orders, checking the formula in every case, and they come from here. If we want to update this model, we come over here, we update it here. If you want to add this information to your scenario, and why wouldn't you, by the way? You can continue down here with your secondary input section and feed directly into there. That would be the next step, by the way, of development of this model by changing some or all of them. I didn't do that because having done this one and these four, it's just a matter of addition or complication to change all of the raw unit information that we see there. What do we find? Well, we find this, that in the best case, all we need to know in the best case at the top level is that under these conditions and these conditions, with these overheads, and I didn't vary the overheads, by the way, and I could have, we find that the ABC cost per unit is 62, 82, 95, as opposed to them, so that we're still dealing with the difference between the different technologies. There you are. I've added the difference between the two systems. 13, 2, and minus 94, which is a good thing. Is it a good thing? No, it's a terrible thing. Best case, 9, well, and again, a difference of 38. It's a bad thing. And most likely 12, 1, and again. So the second reason for doing this, by the way, is Number one is to show scenario management, how you might use it in an exercise like this. And secondly, to point out, if you just explore cost accounting data in this kind of way, even at this very simple top-down level, you will see that product C is a bad idea. It's just not right. When you think you're happily selling 63.79 times 2, 127, something like that, you're making it for 140. It's a disaster. And you can find that with your scenario manager, really very easily. Finally, take it a step further, I've created a couple of charts. What I found now is I put all the 3 scenarios together, units and total sales, units, total sales. So it's going to be something like best case, worst case, most likely, and put it on a graph, and you get, it's discontinuous, it's not a straight line, but you put them on a graph and you see that. It gives you a cost function, an overall cost function, highly correlated. As a general review, and if you change the scenarios in any way, the top left-hand corner, this will change. And then finally, our sensitivity analysis. What we do with this is we take the units, the percentage change from the base case to the best case, units of A, cost of A, units of B, cost of B, sensitivity. So the units change by 111% from base, and the cost changed by almost 100%. Under the worst case scenario, units change by 89% and cost change by 101. Most likely, the base case must be that way. So 111, 99, 117, 99, 167, and 69. So in terms of sensitivity, draw your own conclusion. I've recreated this table here. I didn't need to do it, but it just makes life a lot easier for a reader. So I'll put in the scenario data and then use that to do the calculations there. It is finally unit change, the rates of change. So unit changes, cost changes, put it all in one graph, and we get this spider graph that looks like this. Of course, you have to interpret that. And what is it telling us? Well, look at each in turn. There you are. This one, is it product C? I'm sure it is. There it is. Product C, in the best case, slopes downward from left to right. This one, again, product C. All right, there you are. That's scenario analysis using activity-based costing with this very simple but realistic format, textbook format exam question, and you can usefully use it for scenario analysis, and you can usefully enhance it even more by having your scenarios for this and your scenarios for these, and that will give you a truly comprehensive review of scenarios in activity-based costing. Thank you for watching with me, Duncan Williamson, Between the Sheets, Excellence since 2000.